Well, welcome back to another video on section 7.4. This is the second half of the video for recordings for 7.4. We're going to talk here about dividing radical expressions. And as I told you back when we did section 7.2, there were certain rules for radicals. So today we're going to talk about two more of the rules for radicals. One of them is that you cannot have any fractions under a radical sign. Well, this rule is a little bit easier. We're kind of skirt this one, and we talked about this earlier. If you have a fraction under a radical, what you really should just do is think of it as taking the radicals for each part. So just basically separate the radicals, and then you take the square root of the numerator and the square root of the denominator. So here, if we have the square root of 81 over 121, we just want to think of it as being separated. So that's kind of just think that, and then just take the square root of each one individually. So the square root of 81 would simply be 9, square root of 121, 11. So it will simplify out to be 9/11ths. Now, what else is involved in this is that you still would have to simplify a radical that does not have a perfect square in it. So on the next one, if we look, they'd be the square root of 8 over the square root of 9. Well, the square root of 9 is great because it's a perfect square. That would come out to be 3. But the square root of 8 has a perfect square factor in it. So I need to break apart the 8. I'm going to call that square root of 8 and make it 4 times 2. So the square root's going to get to come out of the 4, which gives me a 2 to bring out. So I'd be left with 2 square root of 2 over 3 for the final answer. Same thing on the next problem. If I have square root of 24 over square root of 49, the 49 is a perfect square, so it comes out to be a whole number with a 7 on it. 24, though, has a perfect square factor in it, so I'm going to use the combination of 4 times 6, and that way I can get the perfect square with the 4. So I'm going to bring the square root of 4 out and give me a 2 on the outside and a square root of 6 on the inside. So when you simplify the radicals, even though they're not fractions anymore, you have to work at them as individuals, and we still have to do the simplify rule. So continue on until this radical right here has no more perfect square factors in it. Alright, and on this one, we've got some variables involved, so we're going to use our rules for variables. I'm going to have the square root of 63w over the square root of 25x to the 4th y to the 8th. Okay, so on the top, I can simplify that out by using 9 times 7. So 9 times 7, that'll give me a square root on the 9. So take the square root of the 9 and bring it out. That's going to leave me a 3 outside, and the 7 and the w will be left over underneath the radical. Then on the bottom, I can take a square root for 25. It's already a perfect square, so I'm just going to pull out the 5 as a square root. Now I have variables. Remember, when you're taking a square root of the variable, that you divide the exponent by this index number, and here it's an understood 2 because it's a square root. So 4 divided by 2 would leave me with an x squared to come out, and y to the 8th, 8 divided by 2 would be 4, so y to the 4th. This would be your final answer. So your radical still has a little bit underneath, but anything else is there. Now, the rule number 3 for radicals. Rule number 3 says there is no radical in the denominator. Okay? If you notice on all of these, it just so happened that the numbers underneath on the denominators were all perfect squares. So those all came out to be good numbers because they were perfect squares. Now down here we're going to see if I do the same process on this first one with the square root of 4 over the square root of 3, and I break it apart, the square root is going to come out to be a 2 on the top because the square root of 4 is 2, but the square root of 3 doesn't simplify, so it leaves a square root on the bottom. So at first it looks like we're okay here, but it violates rule number 3 because we've got a radical in the denominator. So when the radical is in the denominator, we use a process that's called rationalize. What happens is this number, this square root of 3 that's under the radical here, is what we call an irrational number. It's a number that if we punch it in our calculator, and our calculator continues calculating forever and ever and ever, it would never stop, nor would it ever have a repeating pattern in it. So that's what we call irrational. Well, that makes it be not just really good. It's just not a proper place and a proper way for things in math. And so what we do is we do a procedure that we call rationalizing the denominator. Okay, so if I'm going to rationalize the denominator, what I need to do is I need to take this square root of 3, which is an irrational number, and I want to turn it into a rational number. The IZE on this word means to make. So to make rational is what I need to do for this denominator. The way I do that is to just multiply it times itself. You remember the rule that we talked about earlier when we did the first section on this chapter, that if you multiply a radical times itself, that you simply just pull out that number, because the square root of 3 times the square root of 3 would be the square root of 9, which is what we see here, and then the square root of 9 would be 3. So if we can accumulate enough factors of 3 so that we can get its square root, and that is, if it's square, we need 2 factors of 3's, then we would just be able to get that, to simplify this and make it turn out to be a rational number, or in this case, we're looking for a whole number. So if I have the 2 over the square root of 3, what I need to do is multiply the square root of 3 times itself, because then that just pulls the 3 out. So I can bypass this step right here again and just go straight from square root of 3 times itself, gets me a whole number 3. But on the top, the 2 that's on the outside would have to multiply times the 1 that's on the outside of the square root. So 2 times 1 would give me 2 square root of 3. And then I have no more rule violators here. So I don't have a radical on the bottom, I don't have a fraction under the radical, and I don't have any numbers that need to be simplified. So this would be the final answer that you would be looking for the problem that started out like this. Now, always look at the values that you've got under the radical. When you see a radical in the bottom, don't just always assume that I need to just fix that, because sometimes there's not anything that you need to fix. It might work itself out before. So don't just assume rationalize when I see it. These problems will all be examples of something that you probably will have on your homework. So as I work through these, this is be the same thing that you're going to have to do. Here I have a violator, I have a rule breaker, because I have a square root on the bottom. So in order to get this 7 to get out of the radical, I would simply multiply square root of 7 times this one. But when you work with fractions, whatever you do on the bottom, you have to do on the top. So I have to multiply it by square root 7 over square root of 7, which really, this number over itself is really multiplying by 1, which isn't going to change the value. It will change its appearance, but won't change its value. So now on the bottom, that makes me bring out the 7, and on the top, I'm going to have 9 square roots of 7, because the 9 gets multiplied times that 1 out in the front. Okay, so for number 2, I've got square roots here on the top and on the bottom, but notice the square root on the top is going to be a perfect square number. So I get a 7 out of that one, but I'm still stuck with the square root of 5 on the bottom. So what I'll do to finish it out and get rid of the square root on the bottom is multiply it times its own square root. It has to be times a radical. It can't just be a 5 here. So it has to be a radical 5 that you multiply by. That allows you to use this little rule that we've talked about. So that gets me a whole number 5. And on the top, there's a 1 there. So that would be 7 square root of 5. There you got it. Alright, so down here, I need to get this 11y to come out of the radical. So I'm just going to multiply the top and the bottom by the square root of 11y. Now Now my rule on the bottom lets me just bring out 11y. And the 2 is outside, and the square root of 11y is underneath, so nothing gets multiplied, and you just set them next to each other, and that would be your final answer. Now, when you look at this, you see an 11y on top and an 11y on the bottom. You cannot cancel those because this number on top is not 11y, it's square root of 11y. It's some decimal value that we don't know, and it's multiplied times a y. Nothing here can be simplified, okay? If it were to happen that the outside numbers that were neither under the radical could simplify, yes, you could do that. We'll talk about that in a minute. Okay, here, 1 over the square root of 7. I know there's one like this on your homework. It's just like number 9 over the square root of 7. You've got to get rid of that square root of 7. So I'm going to multiply square root of 7 over itself. Then the 7 gets to come out on the bottom, and you have a 1 on the top times the 1 outside, which means you just have square root of 7 on the top. So what we're trying to do here is rationalize the denominator so that this square root underneath that was an irrational number turns out to be a rational number. So it has to come out to be a whole number here. Now, on number 5, the thing we need to look at first is if I were to take this back and break that rule number 2 and put the 8 over the 20, what would that do for me? Well, what does 8 over 20 going to have happen? I could reduce it. So if they're both under the radical and there's a number that can reduce out, I can divide by 4 on the top and divide by 4 on the bottom. And that simplifies out, and then it gives me square root of 2 on top and square root of 5 on the bottom. Now that just makes me rationalize. I still have to rationalize, but I'm going to rationalize with smaller numbers. So before you jump in and say, oh, I'm going to multiply by square root of 20 over square root of 20, look and see 8 over 20, go back and put it as a fraction, and then simplify that fraction before you work about rationalizing. So put a little star if you have one like that on your homework and think about that. All right, here I'm going to get rid of the square root of 5 by multiplying by square root of 5 over itself. So now the 5 gets to come out on the bottom. But this time the 2 and the 5 are both under the radicals, so when you multiply them, the answer stays under the radical. And again, as I mentioned up here, this number is not 10, so 10 can't divide by 5. This number is the square root of 10, which is a little bit over 3, and it's some decimal value, and that number would not divide by 5. So don't look at this as 10. If you're not sure, stick it in your calculator and see that it's like 3.1, and that wouldn't divide evenly by 5. All right, number 6 is the same kind of problem as this, essentially, but we're going to have a radical with a variable on top. So I'm going to multiply by square root of 7 over square root of 7. And on the top, since they're both under the radical, they're going to multiply out and just be 7x. And on the bottom, I get to bring the 7 so that it's not under the radical. And since the top 7 is under a radical and the bottom is not under the radical, there's nothing else I can do, and this would be your final answer. Now, this section only has a couple of problems in the homework section, but rationalizing a denominator, this information is going to be on your quiz, on quiz D, so you need to make sure that you can do this stuff. So I hope this helps you, and we will see you later.